So let's start our revision for lesson 1, 2, and 3 in chapter 6. Let's start now here. This is for lesson number 1, as you remember. Here now we have to solve each equation. Look at number 1. 3 raised to the power 3b equal to 143. So number 1 here, 3 raised to 3b equals 243. As I solve it now, I have to remember that 3 squared is 9, 3 cubic is 27, and 3 to the power 4 is 27 times 9 times 3, sorry. Which is 81. And 3 to the power 5 will be 243. So as you see from here, 3 to the power 5 is 243. So to find the variable b, I need to make them have the same base. So 243 is 3 to the power 5. And on the other side, we have 3 to the power 3. Now, so the first step, I rewrite 243 as a number or a base to a raised to a power. What's the number will be? I have to choose the same as this number. So as we have the same bases now, we can say that 3b equals 5. So b will be 5 over 3. This is here how to find or how to solve the equation. Solve the equation, as you know, it's mean how to find b. Let's now do number 2 here. 16m equals 64. As I told you, I need now to find m. To find m, I need to rewrite 64 as a 16 to power something. Now let's see. 16 to the power 1 is 16. And 16 to the power 2 is 256. So I cannot write 16 as a, or I cannot write 46 as a 16 to power something. So what can I do? I need now to rewrite them, both of 16 and 64. I need now to rewrite them as a number raised to the power something. And let's find a number that is in common. That's when I raise this number to a power, I get 16. And when I raise this number to another power, I get 64. What's the number will be? You can tell me now. 4. Exactly. Let's try. We know that 4 to the power 1 is 4. 4 squared is 16. 4 cubic is 64. So because of that, I can now rewrite 16 as 4 squared. And don't forget m equals 64, which is 4 to the power 3. So now I get it now, or I rewrite them with the same power. So I get it as 4 raised to the power 2m, because as you remember, what did you take in grade 8? If you have a power raised to other power, you have to multiply them. So it comes like 2m equals 4 cubic. So 4 to the power 2m is 4 cubic. As we have now the same basis, so 2m equals 3, so m will be 2.
Was 3 over 2.
3 over 2, sorry. Yes. Is it clear?
Yes, teacher.
Good. Now, let's solve number 3 here. Logarithm to the base 2 of 2p plus 1 equals logarithm to the base 2 of 5p minus 2. I need now to solve this equation. To solve it, I have to need to find p. The first step, you have to make it here. Since we have logarithm to the base 2 on the both sides, the logarithm with the same base, so we can now raise 2 to them. That means they cancel 2 base to the logarithm 2. They cancel each other. Or you can say, without these steps, that you can say logarithm cancel logarithm. So we have it as 2p plus 1 equals 5p minus 2. 2p plus 1 equals 5p minus 2, since you cancel the logarithm. Then here, minus 1 plus, or sorry, minus 5p minus 5p. So now, 2 minus 5, negative 3p will be negative 3. So p equals 1. Is it clear?
Yes, teacher.
So here, if you try p with 1, look here, 2 times 1 plus 1, which is logarithm 3. Here will be 5 times 1 minus 2 will be also 3, so which is logarithm 3. So now you make them equal. Now let's find, or let's solve number 4. In number 4 here, we have logarithm 3 plus logarithm of x minus 7 equals 1. Now, if you have, look at now the left side. If you have logarithm 3 plus logarithm x minus 7, how can we write it here? In logarithm, if they are added, if you expand it, and after you expand it, they are added. So what does it, what they are before expansion?
Multiplied.
Multiplied, exactly. So they are like logarithm 3 times x minus 7. I'll repeat. Here we have logarithm, and this logarithm here is 3. Oh, I mean like this, 2 logarithms are added. So I can write them now as multiply 3 times x minus 7. That's 1. Oh, that's equal 1. Then logarithm 3x, here let's distribute it, minus 21 equals 1. Now in this case, we cannot cancel logarithm because there's no there's no logarithms in the right and in the left. So the only, I mean they cannot cancel them like number 3. The only things, or the only way that I can do it here to cancel the logarithm, that since this logarithm here is to the base 10, I will raise it to 10, the both sides. In this case, I raised 10 to the logarithm of 10 of 3x minus 21 and 10 to the power 1. So Because of that, now 10 will cancel the logarithm. So I have it as 3x minus 21 equals 10 to the power 1, which is 10, plus 21 plus 21. So 3x will equal 31. So x will be 31 over 3. That's it. Now here, be careful. If you have the logarithm as logarithm of 2 plus logarithm of 7. The second one, logarithm of 2 plus 7. Logarithm of 2 times 7. And logarithm of 2 times logarithm of 7. Here now you have 4 cases. You have to differentiate between them. Let's just a second here. Now, the first case here, you have it as logarithm of 2 plus logarithm of 7. Now, in this case here, the logarithm, okay, they are for 2 numbers, and they are the 2 logarithms. Be careful, not the 2 numbers. The 2 logarithms are added. Since the 2 logarithms are added, so I can rewrite it as logarithm 2 times 7, which is logarithm of 14. So the first case here, the logarithms, be careful, the logarithms are added, so I can rewrite them as logarithm, and I multiply the 2 numbers, 2 and 7. The second case here, we have logarithm of 2 plus 7. Now look at here. Here I cannot rewrite it as logarithm of 2 times logarithm of 7. I cannot write it like this. Why? Because they are added. I can convert the logarithm of 2 numbers are multiplied, or I can expand the logarithm of 2 numbers that are multiplied into 2 logarithms. If they are added, if they are multiplied, sorry. So if the two numbers are multiplied or divided, I can only expand it or expand them. If they are the 2 numbers, if they are added or subtracted, I cannot. If they are only multiplied or divided. So in this case, only I can, and for the divide, I can expand it to be as logarithm of 2 times logarithm of 7. This case only, if the 2 numbers are multiplied. In the other case, if the 2 logarithms, not the numbers, the 2 logarithms are added, I can multiply them because they are already expanded, so I can now write them. Is it clear?
Yes, teacher.
Now here, condense each expression to a single logarithm. So here you have to rewrite these expressions in a single logarithm. So here they are already expanded. I need now to write them as a single logarithm. The first one here, we have 20 logarithm of 2 of u minus 4 logarithm to the base 2 of v. So now, in this case here, what did we have? We have 20 times logarithm to the base 2 of u. If there are a multiplied by the logarithm of b, that's mean this logarithm is b raised to the power a. Is it right?
Yes, teacher.
So if the number is multiplied by the logarithm, it's mean they are like a power. So this 20 here is a power for u. So I can rewrite it as logarithm to the base 2 of u to the power 20 minus here 4 logarithm to the base 2 of v. How can I rewrite it here now?
Log 2
to the power
v
of 4.
to the power 4.
Of 4. So it comes like logarithm to the base 2 of v to the power to the v to the power 4. Now the logarithms now are subtracted. So how can I rewrite them?
Make them divided.
Divided. So I can take logarithm here outside, logarithm to the base 2 of u to the power 20 over the logarithm to the base 2 of v to the power 4. And then the two logarithms, like they cancel each other. So it's like u to the power 20 over v to the power 4. This is here. How can I rewrite it now as a single logarithm? Now, let's solve the second one. Do you have any question here?
No,
No,
teacher.
teacher.
Okay. Now, logarithm to the base 5 of u over 2 plus logarithm to the base 5 of v over 2 plus the logarithm of 5, to the base 5, sorry, of w over 2. Now look at the first one here. We have logarithm to the base 5 of u over 2. So can I rewrite it as half times logarithm to the base 5 of u?
Yes.
And the second one, can I rewrite it as half logarithm to the base 5 of v? And the third one also, I can rewrite it as logarithm to the base 5 of w. Now, can I take half as a common factor?
Yes, teacher.
Yes. So it likes half times logarithm to the base 5 of u plus logarithm to the base 5 of v plus logarithm to the base 5 of w. Then after that now, now I can, can I rewrite it here, before that. Now let's come back to the rules of logarithm. If we have a number that is multiplied by the logarithm, how can I rewrite it? As what?
As a power.
As a power. Bravo. So to the power of half. Fine. Now, if the two of the three logarithms here are not added, so how can I rewrite it?
Multiplication.
As a multiplication. Bravo. So it comes like logarithm to the base 5 of u times v times w raised to the power half. So it's the logarithm to the base 5 of. Now, if you have x to the power half, how can I rewrite it? Any number to the power
Square
half.
root.
Square root. Bravo. So it's like square root of u times v times w. Is it clear?
Yes, teacher.
Okay. Now here, you have to expand. Here we have to do the opposite now. Logarithm to the base 9 of a times b times c cubic. So the three numbers now are multiplied, not the logarithms are added. If the logarithms are added, I can make them in a single logarithm. But here now we have it as logarithm of three numbers that are multiplied. So how can I rewrite it now? I will expand it as an addition. Bravo. So it likes logarithm to the base 9 of a plus logarithm to the base 9 of b plus the logarithm to the base 9 of c cubic. So here, the first one, it's already simplified. The second one is already simplified. But look at the last one. We have c cubic. So what can I do with the power here?
It will be 3 log.
Bravo. It will be like 3 multiplied by the logarithm to the base 9 of c. So if I want to expand logarithm to the base 9 of a times b times c cubic, it comes like logarithm of 9 to the base 9 of a plus the logarithm of 9 to the base b plus the 3 logarithm of 9 c. Now let's solve the last one here. Logarithm to the base 8 of x over y to the power 6 over 6. Now here, if I want to simplify it, it's logarithm. Now x over y to the power 6 to the power 6. So that's mean this 6 is raised for x and for y. So it's like x to the power 6 over y to the power what? What is the power that's raised to y here?
6.
No, it is 6. It is multiplied by 6. It will be 36. Bravo.
36.
So it is x to the power 6 over y to the power 36. Then, so I simplify it now. Then after that here, the logarithms are divided, or the two numbers, sorry, are divided. So how can I rewrite it now?
Addition, subtraction, sorry.
Thank you. Logarithm to the base 8 of x to the power 6 minus logarithm to the base 8 of y raised to the power 36. Then after that, did I finish now?
No.
No. What did we have to do then?
6 logarithms.
Bravo. Here they are raised to the power 6. So since it's raised to the power, so that's mean I can put 6 here as a number. So it is 6 logarithm of 8 of 6 minus 36 logarithm y to the base of 8. That's it. Do you have any question?
No, teacher.
Okay.
No.
Now tomorrow, inshallah, we are going to revise how the derivatives of the logarithmic function and of the exponential function and the integral of the logarithm and the exponential function, and we are going to take or solve some examples for them. Thank you so much.